On question 29 and question 30, find the area of each composite figure. So let's talk a little bit about those kind of ideas. So a composite figure, as the name implies, is composed of, that's where the name comes from. Composite is composed, made from multiple shapes, composed of multiple shapes. And those shapes can be anything that you're familiar with, like triangles and squares and rectangles, trapezoids, circles, and in this case, semicircles. If we look at this question number 30, there isn't a specific name for this kind of shape. You can see that it's very helpful that they put some dashed lines in here so that you can see you got a rectangle, and attached to that rectangle, you have a series of semicircles, right? There isn't a name for that shape other than a composite figure because it's composed of shapes that we already have names for and we have area formulas for. Okay, if I look over here on question number 29, you can actually name this instead of going, oh, it's just a composite figure. I don't have a specific name for it. Yeah, you actually do because it's a polygon. Count up these sides. You got 1, 2, 3, 4, 5, 6. This is a hexagon. But do you have a formula for the area of a hexagon? You probably don't. Remember the formulas that we wrote down for middle school math up to this point? You had squares, rectangles, triangles, trapezoids, parallelograms, and then we also did the circle stuff, right? So you don't have a formula for the area of a trapezoid, non-trapezoid, sorry, a hexagon, not just yet anyway. So what we do is we just break it up, kind of like question number 30 did over here already for us, into the shapes that it's composed of. Now, whenever I go to find the area of these, I basically have two methods available, and one of them is maybe a little bit more obvious than the other. So I'm finding the area of composite figures. And what is that word? Figures. Here, let me try that again. Figures. Okay. The first one, the one that is probably most apparent to people, is just adding the separate composed figures areas together. So adding together pieces. And as far as, say, question number 30 goes, you can see that that is probably the best method to use here because you have yourself a rectangle right here, easy to find the area of, and then these semicircles. So as far as finding the area of a semicircle goes, if you have, semicircle just means half a circle, of course. Here's the area formula for a full circle, pi r squared, but then if I want the area of a semicircle, I'm just going to take half of that, so you can just divide it by 2 or multiply it by half. Kind of be careful here because you're needing the radius, and is that the length that you have right here? No, all the way across is going to be the diameter there, so you have to do something in order to get the actual radius, okay? Now, the other method is about subtracting a missing part. Missing piece. All right, now, if I look up here on question number 29, I can tackle this in basically both of these methods, adding pieces together and then subtracting a missing part. The adding of the pieces is probably, like I said, the one that occurs to people most easily. And if I do put an extra little line straight across here, it makes a rectangle and a triangle. Probably not the only way to do this. Of course, you could break it up further in this shape. I put a little extra segment in here. You can see that this is a square. I know it's a square. There's a right angle, and these are 4 by 4 here. Right, and I can just add those individual pieces together because it's very easy to find the area of a square, find the area of a rectangle and a triangle as long as I can find its length and width and base and height and stuff. So as far as that goes, you may have to do a little bit of adding and subtracting to find some indirect measurements. What I mean by that is this. Whenever you go to find the area of this rectangle here, you need its base length and its height, or its length and its width. Well, the height is the same thing as this height of the square, which is 4, but its base length is not given to us. It's definitely not the whole entire 12. You want to basically get rid of this piece that's right here from that 12, and that green piece is the same thing as this green piece up here. As a matter of fact, I can just kind of pick this thing up and then just bring it. Of course, we can see that those 4s are the same, and what I would do is just subtract that away. Okay, so all of that might be fairly straightforward. So now let's talk about that second method here that sometimes is a little bit faster, about subtracting a missing piece. So can you visualize question number 29 as some sort of larger figure that's just missing something? If I add in something like this to the corner, to this white space right here, now I have a figure that I have an area formula for. Can you recognize the shape of this figure? This is a trapezoid, and that's pretty handy because we have the formula for the area of a trapezoid that we previously talked about. You just need the two bases and you need the height. So let's look back at that question. And as a trapezoid, remember, in mathematics, base does not necessarily mean the bottom. The bases on a trapezoid are the sides that are supposed to be parallel to each other. And the parallel sides on this one could actually be two different things, two different sets of things. One of them can be maybe the more obvious, the top and the bottom here. Those two are parallel to each other. And then this distance, this complete distance here, would be the perpendicular height between those two parallel sides, the parallel bases. Now, as far as finding that height goes, here I'd have to add some pieces together indirectly in order to find it. One part is 4, and then I can see this piece over here as 4 could also transfer onto the extra segment that I added for a total length. And I'd add those pieces together to find my height. So the idea on this method is to find the area of the whole entire trapezoid using that trapezoid area formula, and then subtracting away that missing piece, the piece that I actually added in here to complete this figure to make it a trapezoid. So I would subtract away the area of the square. And sometimes that's a quicker calculation to do. I don't have to add, let's say, 4 or 5 pieces, individual pieces together. It's finding one complete area and then subtracting some sort of hole or missing piece away from it. So try to, whenever you're looking at these composite figures, to look at it from both of those angles. Now, unfortunately, on question number 30, this one only works with the additive method, not the subtraction method, because you can't just put extra parts on these curves over here in order to turn it into a shape that makes sense. Now, one of the things that you could do, however, is this. You can take this semicircle here and you can combine it with this semicircle down there, and that would make one complete circle. So instead of finding area of a half and area of a half, that's the same thing as just one complete circle. So sometimes you want to look for opportunities to do those kind of things, combine something up in order to make a shape that, again, that you can find the area for.